All right, let's go ahead and take a look at this warm-up. So in this warm-up, we can see that we have some sets of parallel lines. So we have Q and R, which are parallel, and then also these other lines, which I'm going to highlight in just a second here, T and S, which are parallel. So one of the important things to note when we're dealing with parallel lines and trying to apply the different postulates, the corresponding angles postulate, the alternate interior angles theorem, and so on, we can only do that if those angles are on parallel lines and the same transversal. So what we want to do is keep that in mind while we're trying to explain how angle 16 would be congruent to angle 8. So the angles we're talking about, angle 16 right there. Let me make that a different color. Angle 16 right here, and angle 8. So we can see that angle 16, and let's choose one here, angle 4, are both on these parallel lines, Q and R, and they have the same transversal, line T. And since those angles are both on parallel lines and share a transversal, we can apply the corresponding angles postulate. And then, similarly, we can say that angle 4 and angle 8 are both also on parallel lines, S and T, and have the line Q in common as their transversal. So again, we can apply the corresponding angles postulate to say that those would be congruent. And by doing so, we've created this chain of congruence that connects angle 16 to angle 4 and then to angle 8. So we know all of these are going to be congruent to one another. And we can kind of write this out like a proof. We can say that angle 16 is congruent to angle 4 because of the corresponding angles postulate. We can say that angle 4 is congruent to angle 8 because of the corresponding angles postulate. And then finally, by the transitive property of congruence, we can say that angle 16 would have to be congruent to angle 8, again, by the transitive property of congruence. That's not the only direction that we could take this proof. I just want to illustrate that we could have done this in a couple different ways if we wanted to be a little fancier or something like that. So let's say instead, we could say that angle 16 and angle 2 would have to be congruent because they are alternate exterior angles. And then 2 and 8 could be alternate interior angles, so those would be congruent. So we could have created another chain based on different reasons. We don't just have to use corresponding angles, but we do have to make sure that the angles we are connecting with any given statement like this do have parallel lines with the same transversal. All right, let's go ahead and talk about the second one. Angle 2 is supplementary to angle 9. All right, so angle 2 and angle 9. Angle 2 is here, and angle 9 is here. We have a similar problem. These angles are on parallel lines, but they don't have a common transversal. So we're going to have to make some connections here. We have a lot of options. What I'm going to do is this. I'm going to say, instead of angle 2 being supplementary to angle 9, I'm going to say angle 2 is supplementary with angle 5, because those are same side interior angles. So the measure of angle 2 plus the measure of angle 5 equals 180, because those are same side interior angles theorem. And angle 5 and angle 9 are congruent because they are corresponding angles with a common transversal. So that is the corresponding angles postulate, which also means that the measure of angle 5 would be equal to the measure of angle 9. Right? That's a direct result based on the definition of congruent angles. By knowing that, we can replace angle 9 in this statement and say that the measure of angle 2 plus the measure of angle 9 is equal to 180. Again, using the substitution property of equality. And that's the same thing as saying that they are supplementary to each other. They add to be 180. All right, so let's go ahead and do this example of proving some lines that are parallel. I'm going to go ahead and mark out what we're given here. So it's given to us that we have two parallel lines, M and N. So it's this line right here, M, and this line right here. And these are given to be parallel, which means that we can use things like corresponding angles or alternate interior to connect this grouping of angles right here and the other grouping over there. Let me just kind of highlight those real quick. So we can use corresponding angles and such to connect angles in between here and here. And our goal is to demonstrate that line L, so this one here, is parallel to N. So remember, to do so, that means we're going to need to show that we have some corresponding angles or alternate interior or anything like that that has the relationship that they're supposed to have. Something that I said previously is you could sort of use some of the information about what angles are labeled to give you a hint. This one, everything is labeled, so it seems like I kind of have my choice. The other given is that angle 2 and angle 10 are congruent. Okay, so those are alternate interior angles. So that could let us say that L and M are parallel. That's not what we're trying to get to, so I'll have to kind of make use somewhere else. So just to set a path for this proof, I'm going to try to show that angle 6 and angle 2 are congruent. That's going to be my goal. That's going to be the way that I show that L is parallel to N. I'm going to show that these corresponding angles are congruent. So the reason here will be the converse of the corresponding angles postulate. If I can show these corresponding angles on lines L and N are congruent, then the lines will be parallel. I don't know how I'm going to get there yet. I have some ideas, but I don't know the exact path that I'm going to take. We don't know that to be true yet. Okay. So let's go ahead and list out the given information first here in the proof. M is parallel to N, and angle 2 is congruent to angle 10. This is given. Just gonna make some lines here. So this is gonna be all about filling in the middle. I don't know, I'm gonna need to get from here to here. So I need to create some sort of a chain that connects angle 2 to 6. Right now I have angle 2 is congruent to 10. Can I get from 10 to 6? And well, I can. If I look here, these lines are parallel. They have a common transversal. Angle 10 right here and angle 6 are alternate. They're on different sides of this transversal, and they're both in the exterior of these parallel lines. So they could be considered alternate exterior angles. Thus, they should be congruent. So angle 10 is congruent to angle 6 because of the alternate exterior angles theorem. So alternate exterior angles theorem. And we've actually already created our chain. We have angle 2 is congruent to angle 10. Angle 10 is congruent to angle 6. That has created our chain for us. So by the transitive property of congruence, we can say that angle 2 is congruent to angle 6. And since those are corresponding angles, lines L and N must be parallel to one another. This is not the only way we could have gone about this proof. We could have set up another goal for ourselves to give us that. We could have maybe shown that 2 and 8 are congruent and used converse of alternate interior angles, because 2 and 8 would be alternate interior. but that's the way we did this one in this case. Oops, did not mean to stop my screen share. All right. All right, so we're going to talk about our next example here. We have a couple sets of parallel lines. We can see that P is parallel to Q, and R is parallel to S. That is given to us. Our goal, what we're trying to prove is that angle 1 and angle 4 are supplementary. Now, we could actually create a connection here, 1 and 4. Those don't fall under our any of our angle relationships that we know. These are not corresponding or alternate interior or same side interior or anything. Based on the way these things are sort of labeled, it actually looks like I'm supposed to connect angle 1 to 2 to 3 to 4 to do it this way. That doesn't seem to be the most efficient, but it shows kind of a pathing that we may want to use. So let's just go ahead and do it that way. So our givens here are P parallel to Q, and R is parallel to S. The next thing that we can say, since these are parallel lines, we can say that angle 1 is congruent to angle 2, and those would be considered corresponding angles, so we call that the corresponding angles postulate. Angle 2 and 3 are also congruent because they are also corresponding angles. So I'll also use the corresponding angles postulate there. And 3 and 4 are supplementary. So what we need to do here is I want to make a replacement here. So I can say that 3 and 4 are supplementary, but I want to say that 1 and 4 are supplementary. This right here gives me a nice chain. Angle 1 is congruent to angle 3 by the transitive property. It's the transitive property of equality. When we have congruent angles, by the definition of congruent angles, that means these measurements are going to be equal. That's the definition of congruent angles. And then I want to use that to make a substitution here. So looking at this picture, I can see that angle 3 and 4 are same side interior angles. So I can say the measurement of angle 3 plus the measurement of angle 4 has to equal 180 degrees by the same side interior angles theorem. They are on the same side of this transversal interior between the parallel lines P and Q. And if we make a nice little substitution here, we can change this to the measurement of angle 1 plus the measurement of angle 4 equals 180. That is substitution. And because I'm out of space here, I am not going to write my final statement. My final statement would be that those angles are supplementary because we have shown they have the mathematical relationship of supplementary. So that is the definition of supplementary angles. That would be our last statement and reason right there. Go at the bottom. That was trickier than it needed to be. If I was going to do this proof in a different manner, I think I would have created a special angle 5 and said angle 1 is congruent to 5, 5 and 4 are supplementary, and done the replacement right there. That would have been a much shorter path. Instead of going 1 to 2 to 3, 3 and 4, and then substituting. I could have just done 1 is congruent to 5, 5 and 4 are supplementary, and then done my substitution there. But you know, gives it the idea that sometimes you need to kind of work your way around in these problems. All right. Homework here. Remember to turn in number 10 on Google Classroom, and we will be reviewing chapter 3 starting tomorrow. I'll see you guys later.